Insulating pipes in electrical rooms requires careful consideration of several factors, primarily focusing on preventing heat transfer and ensuring fire safety. Insulating foam is one option, with closed-cell foam insulation such as polyisocyanurate, also known as PIR, or polystyrene, also known as EPS, providing excellent insulation and protection against heat transfer. Mineral fiber insulation is another choice, with rockwool or fiberglass insulation offering thermal and acoustic insulation, but it may require additional measures to protect against moisture. Calcium silicate insulation, an inorganic material, is fire-resistant and provides thermal insulation, but it can be brittle and difficult to handle. A ceramic blanket is a high-temperature option, able to withstand extreme heat and insulate pipes effectively. They are also flexible and easy to install. When selecting insulation, several considerations are paramount. Firstly, temperature rating is important. Ensure that the insulation material has a temperature rating that exceeds the maximum expected operating temperature of the pipes. Secondly, fire resistance must be considered. Use insulation materials that are fire rated for at least 2 IOs to meet code requirements. Thirdly, moisture resistance is key. Choose insulation materials that are moisture resistant or waterproof to prevent corrosion of pipes. Fourthly, ease of installation is a factor. Consider insulation materials that are flexible and easy to wrap around pipes, especially if space is limited in the electric room. Alternative methods to insulation may also be considered. 1. Pipe separation involves relocating the pipes to a separate location outside the electric room, maintaining the required separation distance from electrical equipment. 2. Enclosed conduit provides an option. Install the pipes within an enclosed metal conduit that provides physical protection and thermal insulation. If boxing in the pipes with 2 IO rated gypsum board is not feasible, wrapping the pipes with a high-temperature ceramic blanket is an option. This material offers insulation, fire resistance, and flexibility, making it suitable for this application. When choosing an insulation material, carefully evaluate its thermal conductivity, which is a measure of its ability to conduct heat. Low thermal conductivity indicates better insulation performance. Consider the density of the insulation material. Higher density materials generally offer better thermal performance, but may be heavier and more difficult to handle. Check the manufacturer's specifications for the insulation material to ensure it meets the required performance standards for the application. Ensure that the insulation material is compatible with the pipe material to prevent corrosion or other adverse reactions. Properly seal all joints and seams in the insulation to prevent air leaks and maintain consistent thermal performance. Consider the long-term durability of the insulation material and its resistance to degradation from environmental factors such as ultraviolet radiation and moisture. Consult with a qualified engineer or insulation specialist to determine the most appropriate insulation material and installation method for your specific application. When installing insulation in electrical rooms, ensure that all work is performed by qualified personnel in accordance with relevant safety standards and building codes. Regularly inspect the insulation to identify and address any damage or deterioration. Be sure to comply with all relevant regulations and guidelines. Different jurisdictions may have specific requirements for pipe insulation in electrical rooms, so it is essential to comply with all relevant regulations and guidelines. The National Electrical Code, also known as NEC, provides guidance in the installation of electrical equipment in buildings, including requirements for fire stopping and protection of electrical systems. Local building codes may have additional requirements for pipe insulation in electrical rooms, such as specific fire resistance ratings or material specifications. Consult with local building officials or fire marshals to ensure compliance with all applicable codes and regulations. Obtain the necessary permits and approvals before starting any insulation work in electrical rooms. Maintain detailed records of all insulation materials used, installation procedures, and inspection results for future reference and compliance purposes. Consider using a combination of insulation materials and methods to achieve the desired level of protection and performance. For example, You could use a layer of mineral fiber insulation covered with a layer of fire-resistant coating for enhanced fire protection. Explore innovative insulation technologies, such as vacuum insulation panels or aerogel insulation for applications where space is limited or high performance is required. Pay close attention to detail during the installation process to ensure that the insulation is properly applied and sealed. Overlap insulation joints to prevent thermal bridging, where heat can transfer through gaps in the insulation. Secure the insulation to the pipes using appropriate fasteners or adhesives to prevent it from sagging or shifting over time. Protect the insulation from physical damage by installing a protective covering or barrier. For example, you could use a metal or plastic shield to protect the insulation from impact or abrasion. Ensure that the insulation does not obstruct access to electrical equipment or interfere with the operation of electrical systems. Maintain adequate ventilation in the electrical room to prevent the buildup of heat and moisture. Consider using a vapor barrier to prevent moisture from migrating into the insulation and reducing its effectiveness. Choose insulation materials that are environmentally friendly and sustainable. Look for products that are made from recycled materials or that have a low environmental impact. Properly dispose of any waste materials generated during the insulation process in accordance with local regulations. Conduct regular energy audits to assess the performance of the insulation and identify opportunities for improvement. Consider using thermal imaging to detect areas of heat loss or air leakage in the electrical room. Implement a preventative maintenance program to ensure that the insulation is properly maintained and repaired as needed. Consider the impact of the insulation on the overall energy efficiency of the building. Properly insulated pipes can reduce heat loss and save energy. Evaluate cost-effectiveness of different insulation options based on their performance, durability, and ease of installation. Consult with experienced professionals in the fields of electrical engineering, mechanical engineering, and building science to obtain expert advice and guidance on pipe insulation in electrical rooms. Consider the potential for condensation to form on the pipes and choose insulation materials that are resistant to moisture and mold growth. Pay attention to the aesthetics of the insulation installation. While functionality is the primary concern, it is also important to ensure that the insulation is installed neatly and professionally. Consider the potential for future modifications or repairs to the pipes and choose insulation materials that can be easily removed and reinstalled. Properly label all insulated pipes to identify their contents and purpose. Regularly inspect the insulation for signs of damage or deterioration, such as cracks, tears, or moisture damage. Repair or replace any damaged insulation promptly to maintain its effectiveness. Consider the impact of the insulation on the acoustic performance of the electrical room. Insulation can help to reduce noise levels and improve the comfort of occupants. Choose insulation materials that are resistant to pests and rodents. Pests can damage insulation and reduce its effectiveness. Ensure that the insulation is properly supported to prevent it from sagging or collapsing under its own weight. Consider the potential for vibration in the pipes and choose insulation materials that can withstand vibration without becoming damaged. Pay attention to the details of the insulation installation, such as properly sealing penetrations and ensuring that the insulation is tightly fitted around pipes and fittings. Regularly review and update the installation plan to reflect changes in building codes, regulations, and best practices. Consider the use of smart insulation technologies, such as self-adjusting insulation or insulation with integrated sensors, to optimize energy efficiency and performance. Educate building occupants and maintenance staff on the importance of proper insulation and how to identify and report any problems. Implement a system for tracking and managing insulation-related data, such as installation dates, materials used, and inspection results. Consider the use of life cycle cost analysis to evaluate the long-term costs and benefits of different insulation options. Consult with industry experts and participate in professional development activities to stay up to date on the latest insulation technologies and best practices. The selection of insulation should involve assessment of the risk of corrosion under insulation. This is a phenomenon where moisture can penetrate the insulation and lead to corrosion of the underlying pipe. Using materials with low water absorption and proper sealing techniques can mitigate this risk. Insulation material should not contribute to the spread of fire. Materials are tested for their flame spread and smoke development characteristics. Choose materials with low flame spread and smoke development indices to minimize fire hazards. Be aware of the health and safety aspects of insulation materials. Some materials may release harmful fibers or chemicals during installation or removal. Use appropriate personal protective equipment, also known as PPE, and follow manufacturer's instructions to minimize exposure. The weight of the insulation can add significant load to the piping system, especially for long runs or large diameter pipes. Ensure that the piping supports are adequate to handle the additional weight. Insulation can also affect the flexibility of the piping system, especially for systems that are subject to thermal expansion and contraction. Take this into account when designing the piping system and selecting insulation materials. The cost of insulation can vary depending on the material type, thickness, and installation method. Perform a cost-benefit analysis to determine the most cost-effective insulation solution for your specific application. Some insulation materials may be susceptible to damage from ultraviolet radiation, also known as ultraviolet or UV. If the insulation is exposed to sunlight, choose a material that is UV resistant or provide a protective coating. The insulation should be compatible with the operating temperature range of the piping system. Some materials may degrade or lose their effectiveness at extreme temperatures. Ensure that the insulation is installed in accordance with the manufacturer's recommendations. Improper installation can reduce the effectiveness of the insulation and may even create hazards. Regularly inspect the insulation for signs of wear and tear, such as cracks, tears, or compression. Replace damaged insulation promptly to maintain its thermal performance. Consider the environmental impact of the insulation material. Choose materials that are sustainable and have a low carbon footprint. Insulation can also help to reduce noise transmission through the piping system. If noise control is a concern, choose a material with good sound absorption properties. The thickness of the insulation will affect its thermal performance. Thicker insulation will generally provide better insulation, but it will also be more expensive and may require more space. Consider the space constraints when selecting the insulation thickness. The insulation should be designed to prevent condensation from forming on the pipe surface. Condensation can lead to corrosion and mold growth. The insulation should be resistant to chemical attack. If the piping system is exposed to corrosive chemicals, choose a material that is compatible with those chemicals. The insulation should be easy to clean and maintain. If the insulation is likely to get dirty, choose a material that can be easily wiped down or washed. The insulation should be durable and long-lasting. Choose a material that will withstand the rigors of the environment and provide years of reliable service. Consider the life cycle cost of the insulation. This includes the initial cost, the cost of installation, and the cost of maintenance. Choose a material that will provide the lowest life cycle cost. The insulation should be designed to minimize air leakage. Air leakage can reduce the effectiveness of the insulation and increase energy costs. The insulation should be designed to prevent thermal bridging. Thermal bridging occurs when heat can flow easily through a conductive material, such as a metal fastener or support. The insulation should be designed to minimize heat loss from the piping system. Heat loss can increase energy costs and reduce the efficiency of the system. The insulation should be designed to maintain the temperature of the fluid in the piping system. Maintaining the temperature of the fluid can improve the performance of the system and reduce energy costs. The insulation should be designed to protect the piping system from freezing. Freezing can damage the piping system and cause leaks. Consider the use of heat tracing in conjunction with insulation to prevent freezing in cold climates. Heat tracing is an electrical heating system that is installed along the piping to keep it warm. The insulation should be designed to protect personnel from burns. If the piping system is hot, the insulation should be thick enough to prevent personnel from coming into contact with the hot surface. The insulation should be designed to protect the piping system from mechanical damage. Mechanical damage can compromise the integrity of the piping system and lead to leaks. The insulation should be designed to be easily accessible for maintenance and repairs. If the piping system needs to be accessed for maintenance or repairs, the insulation should be easy to remove and replace. The insulation should be designed to be aesthetically pleasing. While functionality is the primary concern, the insulation should also be visually appealing. Consider the use of colored or textured insulation to enhance the appearance of the piping system. The insulation should be designed to meet all applicable codes and standards. Codes and standards may specify requirements for insulation thickness, fire resistance, and other properties. The insulation should be designed to be environmentally responsible. Choose materials that are sustainable and have a low environmental impact. Consider the use of recycled materials in the insulation. Consider the use of renewable energy sources to power the insulation system. Regularly inspect the insulation system to ensure that it is functioning properly. Repair or replace any damaged or deteriorated insulation. Keep records of all insulation work, including installation dates, materials used, and inspection results. Train personnel on the proper operation and maintenance of the insulation system. Work with a qualified insulation contractor to ensure that the insulation system is properly designed and installed. The properties of the fluid being transported should be considered. For example, if the fluid is highly corrosive, a corrosion-resistant insulation material should be selected.